Welcome to Euprime podcast. These are a bunch of podcasts that we are doing that should be in the public domain. These are being done for the public interest. So we get started with the opening podcast. Let me introduce the people here. There is Vinita, there is Flynn, there is Gautam, and then it's me, Akash.
This Flynn and Akash, I came up with this crazy article on LinkedIn. So it basically said math beats science.
What's crazy about the article?
Math beats science.
Okay.
So, how do you prove that?
Okay, so basically, what I'm trying to say in the article is like mathematics has always sort of been married to other subjects.
Yeah.
It so happens that we live in a period right now that it is the case for its importance is more than before. So so I go out giving examples as to how in the past for like last 100 years there has always been a tendency from other disciplines like physics to have an inkling towards mathematics. For example, in things that you prove in physics, especially the example that I've stated in the article is pertaining to geometry and how that is related to uh, the physics
Yeah,
aspect.
the Einstein's theory of relativity.
Yeah,
And you had compared that with Rieman's this one concept of three-dimensional world and
yeah. So
Minkowski's
yeah,
theory.
the
So,
reason I bought Riemann in the context here is like Riemann died in 1870s. So Riemann literally had the conception of three-dimensional space, which was quite well known to people for about 30 years. So Minkowski, and people expect you to know.
with a superhero.
Yeah, they imagine the Nobel Prize winners to be some sort of Renaissance man of 16th century. It's like a Leonardo da Vinci Prize. So they expect you to know everything about every topic, which isn't the case. Nobel Prize is given to a very specific work in a very narrow discipline in that basic sciences. So that might probably be the reason why physicists or people who win prizes in chemistry are more in the limelight or known more to the world than other people. And also, physics answers one of the fundamental questions about life as to the origins of life, as to how we came along, and what is the purpose and stuff, and which mathematics doesn't. So that might probably be the reason why mathematicians are literally unknown to this very day.
Okay, on the basis of the same questions, I had this theory that like every invention that comes up or anything which people create is inspired or is like pulled out from some other previous work.
Yeah,
And in this case, Einstein's work, which became a big hit, was inspired by few mathematicians.
yeah.
So that doesn't make Einstein's work less relevant, does it?
No, it doesn't make it more relevant. See, every discovery that happens, people stand on the shoulders of giants, as it were.
Yeah.
So the theory that Einstein is famous for was proposed by Lorentz before, and he came along and he had a different view of how gravity ought to look like in the general scheme of things.
Right.
So there are, I mean, I wouldn't presume to speak for all physicists. Probably a physicist would be more qualified to talk about these subjects, but on a general view, I mean, it's quite common in every discipline that people take inspiration from the past work and they build on it.
Okay.
It's a natural consequence of being in a discipline.
All right. Yeah. And one more thing. There was a phrase that you mentioned in the article that was math is more structured and has reasoning.
Yeah,
Yeah.
yeah.
So do you think science doesn't have structure or reasoning?
Oh, okay. So I was let me get the context here. Like I was using the words reason and structure in the context of disproving a popular myth that mathematics is all about numbers and calculations, which isn't the case.
Yeah.
We have been fed up in this education system wherein people think if you add up a couple of numbers quickly, you're numerically very aware, which is true, but that discipline is not called mathematics. That discipline is called arithmetic, and mathematics is not arithmetic. And the real mathematics is something that is more close to logic, wherein like you have to make a statement and have a deductive reasoning scheme in which you make consecutive statements and you prove something. So that would mean it's more reasoning based, is what I meant. I didn't think like physics is not reasoning based. Even for that matter, disciplines like physics and chemistry borrow the language of mathematics and use it extensively in publishing any paper. So if you take up any stereotypical garden variety physics paper, you will probably see a smattering of mathematics in all the pages, which is because mathematics is a language that gives you clarity and gives you precise way by which you can communicate complex ideas.
Right.
So that hasn't been displaced yet. So mathematics has been a lingua franca in scientific communication.
True. And one last question based on what you said before, that people think maths is all about calculation and your counting skills. And that is actually arithmetics, not mathematics.
Yeah.
So in your article, you have said that the real math starts when you are getting into undergrad. Right?
Yeah.
So how, like, if you had to change something about, like, so many smart kids are out there who do not take math because they think it's all about numbers.
Yeah.
Right. So if you had to change something about the current system to make sure that kids these days understood what real math was, what would you do?
So if you go to a music class, and I think you will be more qualified to understand this.
Yeah.
You don't. So if you go to a music class, you won't be given a guitar and you will be asked to play anything that you want, right?
Yeah.
So you'll be shown the works of the masters that have come before you, and you will draw inspiration from these masters and then try to compose music, as it were. Mathematics, nobody knows about the masters that have lived before and their work. If you go to any European city, you'll see a lot of monuments and museums built on art. People draw inspiration from art and then they try to become artists, which isn't happening in mathematics. So if you ask if you take a survey of any random 100 people and ask who the great mathematicians are, unless they have heard the person's name in popular media or in television, they won't know what the previous work is. So that's a major fact as to why people are not drawn to this. And I would go as far as to say not drawn to it. They're repulsed by the subject. They're repulsed by the subject because they don't know the beauty and the structure that exists in it. And that's one of the reasons people give up on it long before they're even made aware as to what it is.
That's true.
Yeah.
So yeah, I do hope that kids kind of try and learn from the experts.
Yeah, and now you have an economic motive.
Yeah, that's
I describe in the very first paragraph that society, the social ladder, as it were, the economic ladder of society, is literally divided based on your familiarity with the mathematics or not. I mean, if you're familiar with mathematics, it might so happen that you will end up in a job and a lifestyle which would kind of lend itself to a comfortable life. If you're not familiar with it, you might as well work for somebody who is probably more familiar and is more comfortable with that language. So it's not about choice anymore. You either learn it or you don't. If you don't learn it, and the fact that now computers play such a critical role in our society, even if you want to do biology and you want to prove something, it has to be through simulations because you cannot enter a real body and do an experiment, as it were. So the scientific method, if it has to proceed in any other discipline, has to take mathematics into account, has to take computers, and it's almost vital that you learn mathematics now. I mean, it's come to a point, and the vitality will increase over a period of time as opposed to go down the other way.
If I was just going to ask you, explain the general equilibrium of economics.
Yeah.
What would you explain?
So, general equilibrium is like you have a theory of consumers and you have theory of investment. And general equilibrium is if there is one theory that describes it all, that incorporates every agent in society, so that they have some sort of a structure based on which you can derive every other theory. That's what we refer to as general equilibrium. So in this context, I was referring to general equilibrium theory or now as people call it, the neoclassical
So
equilibrium.
you said von Neumann actually gave a structure to it, and then when you said von Neumann gave a structure to it.
Yeah. So von Neumann Oscar Morgenstern is an economist who worked with von Neumann, and they came up with the initial paper in 1928 called the Theory of Games and Economic Behavior, and they wrote a detailed treatise on in 1944. And economics handles uncertainty, or the idea of uncertainty exists in economics. So you want to know how to handle it in a theoretical framework, in a scheme of sorts. And von Neumann was of the opinion that you should think of, at the time in the 1920s or in 30s, there was a view that lot of calculus-based mathematics has permeated economics, but a lot of the economics questions are wrong and not consistent throughout the scheme. So what he said in the beginning of the preface that he wrote in the book is that a lot of the economic questions are posed in a wrong manner. So he said, let's take up economic behavior that is very much known to everyone, like individual behavior, like two people meeting in an actual discussion and having a negotiation over a price of a commodity, simple things that anyone can understand. So you build theory from that point onwards, as opposed to directly deal with countries and national policies, things which are very abstract in nature, for which you don't have a real empirical basis. So he said, like, let's take up individual behavior of consumers and deal with it.
Yeah, you said that when you speak about modern mathematicians, Euler is the first person that comes to your mind. Even though he was from the 17th. So what makes him different from the other mathematicians?
So Euler came up with the idea that apart from writing Calculus of Variations book, which is one of the initial treatments of that subject, whose methods are used to this very day in economics, he came up with the idea. Ideally, what you would say is, like, if you take any polygon and if you count the number of sides and the number of edges and the number of nodes, there is a nice formula that comes along. So he was one of the first person to have a conjecture of that sort. This conjecture stands true for all things with all polyhedron. So polyhedron would mean like a cup with a protruded handle wouldn't be a polygon because it has some space in it. So any other polygon would fit the description, and you can probably verify his formula, and this holds true even to this very day. And so if a theory has stood the test of time for 350 years, it deserves its limelight. So the person who conjectured it at the time he did it, he had very little means to know it, and he was able to do that. So that's why he's the first pure mathematician. There were other people like Leibniz and Newton who were around that same period, but they were more physicists than mathematicians. He was the pure mathematician. That's why I took him as the first pure mathematician of modern era. Thanks everyone for watching the podcast. I hope you had a good time understanding and listening to all these things. Hope you come back and watch more. Thank you.